this lesson is on triangle similarity, specifically AA, SSS, and SAS. If you'll recall, these two acronyms look very familiar because we have the side-side-side and the side-angle-side used when we were proving two triangles were congruent. Well, these can also be used to prove triangle similarity. If we look at our three postulates, or postulate two theorems for this particular lesson, let's kind of evaluate what it is that could cause us to say two triangles are similar. The first postulate says that if two angles of one triangle are congruent to two angles of another triangle, then the triangles are similar. So if you look in my diagram here, I've got angle A and angle D are congruent together, and angle B and angle E are congruent together. If you can't really see it, let me highlight this there. They were both marked one there, and this one was marked twice here. So I know for a fact that these would be our angles that would be congruent. Therefore, I've got two sets of congruent angles within the triangles. I can say that the triangles are actually similar. If we look at the next theorem, it says if you have three sides of one triangle are proportional to three corresponding sides of another triangle, then you can say the triangles are similar. Well, that would mean that AB has got to be proportional to DE, and AE has got to be proportional to DF, and BC has got to be proportional to EF. If that's the case, then you can say the triangles are similar. And then finally, the next theorem. If two sides of one triangle are proportional to two sides of another, and their included angle is congruent, then the triangles are similar. So in this, let's go ahead and assume that AB is proportional to DE, BC is proportional to EF, and then this angle right here would be their included angle. If they're congruent, then we can say that these two triangles are similar. So let's look at our first example. It says, explain why the triangles are similar and then write a similarity statement. Well, look at this, and right off the bat, I see that angle A is going to be congruent to angle D. Why? Because all right angles are going to be congruent. That's the right angles congruence theorem. And then I also know for a fact that this angle here, BCA, is going to be congruent to this angle here. I'm going to do 2 marks on this. ECD. Why? Well, these are vertical angles, and vertical angles are always going to be congruent. So I can also say that angle BCA is congruent to angle BCD. And so now I have two sets of angles that are congruent to two sets of angles. So now I can say triangle ABC is similar to triangle. Let's match it up. What goes with A? The letter B. What goes with B? The letter E. And what goes with C? The letter C. So these two triangles are going to be similar. In example 2, we've been asked to verify that the triangles are similar, slightly different, because now we see our numbers to tell us how long these different segments are. So I'm going to start by comparing PR to the side that it goes with, and that would go with the SU side. I'm also going to compare the RQ side with the side that it goes with, TS here. And then I'm going to compare the PQ side with the side it goes with, which would be our TU. And now we're going to go ahead and see what kind of fractions we get here. The length of PR is 2, over SU is 3. The length of RQ is 3, over TS is going to be 4.5. And then PQ is 3 over 4.5. Well, what I can do is I can go ahead and take my calculator, and I know that these are whole numbers. I'm going to go ahead and look at what 3 divided by 4.5 is. I'm going to get a decimal, and depending on what type of calculator you have, you can change that back to a fraction. And you'll see that that creates the fraction 2/3. So this is equal to 2 over 3, and this is equal to 2 over 3. Well, if you'll notice, all of these sides have the same ratio of proportion, or they're proportional. So I can say that these two triangles, triangle PQR, is similar to triangle STU because of the side-side-side similarity theorem. Similarity theorem. You're also asked to go ahead and find missing links sometimes too. We're told in this problem that these two triangles, the smaller one is going to be similar to the larger one, and so we've been asked to find CD, the length of CD, which is this one here. Well, to do that, you're going to have to set up a proportion. So let's look at the smaller triangle right here. I'm going to use the side 9. And what does that go with on the larger triangle? This side here, AC. So AB is going to be proportional to AC. Or these sides are going to correspond together. Well, what's the whole length of AC? Well, 9 plus 3 is 12. Alright? And then, if you'll notice, this was the small, and again, this goes back to saying, hey, let's just label these things. Small to big is equal to small to big. So you want to make sure that the next number we put on top is going to be from the small triangle. And look, we're trying to find CD, which is this side. So the side it corresponds to on the smaller triangle is this side. So here's my smaller, it's 5. So with the small side, we put a 5. Over my bigger triangle, here's going to be the x. Now I've just got a proportion I'm ready to cross multiply. 9 times x is equal to 12 times 5. And so what you'll do from here is you're just going to go ahead and solve this like it's a basic equation. So you're going to do 12 times 5, which would be your 60. So 9x is equal to 60. And then we're going to get x by dividing 60 by 9. Now I can tell you right off the bat this is not going to be a whole number, so we're going to have to round a little bit. So x is about 6.7 units. That would be my answer. Finally, in this last problem here, we're going to go ahead and do a proof. Now, when we do a proof, just remember that you got to take this step by step. And we probably did this in class, but it's just a good way to review it. So statements and reasons. It tells me that 3 UTs are equal to 5 of the RTs. So we're going to see that these two are going to be corresponding sides. So let's start with that. Number 1, 3 UT is going to equal to 5 RT. And the reason is that that is given. But then also, if I look at this, I really want to kind of get this in terms of comparing the sides. So I'm going to just show you something here to the side. I'm going to pull this down just a little bit so that you can see how I come up with this next statement. 3 UT is equal to 5 RT. I got that from the given. If I divide both sides by RT, that cancels here. And what I'm left with is 3 UT over RT equals 5. Now I want to move this number away. So this is 3 times UT, so how do I get rid of it? Really, you can like multiply by a third or divide both sides by 3. It's really what we're doing is we're just dividing by 3. And so that gives me UT over RT equals 5 thirds. That's my statement number 2. My statement number 2 is going to be UT over RT is equal to 5 thirds. What did I do? Well, I just divide it. So this is the division property of equality. Then we're going to look at doing number 3, which is I've kind of run out of this. I'm hitting a dead end, so I'm going to go back to the next part of the given statement. 3 of the VTs is going to equal 5 of the STs. And so, again, those are going to be corresponding sides, and so that is given to me. And I'm going to do the same process that I did in the previous problem. I'm going to divide both sides by 3 and divide both sides by ST. When I do that, VT is going to be on the top, and if I divide by ST on this side, they'll cancel, but it's going to leave it on the bottom here. And if I divide by 3 here, it's going to leave me with 5 thirds over here. So number 4 is, again, that division property of equality. Now, if you notice, these are the same exact proportions. So the sides are going to be proportional, which means I've got 2 S's. This side right here went with this side right here, and this side right here went with this side right here. So what's their included angle? It's this one right here. And I can actually say that these 2 angles are congruent because they are vertical angles. So number 5, I'm going to say angle STR is congruent to angle UTV. And the reason is the vertical angles theorem, which says all vertical angles are congruent. And then finally, if I know that these are congruent and I've got proportional sides, what I can say is that I can say triangle UVT is similar to triangle RST. Why? Well, that's going to be your SAS similarity theorem.